Hey everybody, this is Larry. This is day 22 of the January Leetcode Day Challenge. Hit the like button, subscribe button, join me in Discord. Let me know what you think about today's problem, if it ever loads. There's also the weekly problem. Today's a easy, yay! Get to rest a little bit. I don't know. Maybe at some point I'm gonna end my streak. Let me know in the comments what you think, because I feel like if I'm like excited not to do it, then maybe I don't know. Is this the best use of my time? I don't know. And most of these problems I've solved already, right? People make it sound like, I'm trying to hide. Maybe not all of you. This is an easy one anyway, so I don't even know if anyone's clicking on this. But sometimes people make it sound like I'm trying to pretend I didn't solve this so that I could solve it later to look smart. And one is, if you ever actually watch these videos, I make so many mistakes. It is not a bragging anyway. Like, it's like, yeah. I prepared, and I mean that might be even be worse if I'm like prepared and I still whatever. But the second is that my friend actually, or someone on Discord, whom reminded me that I've solved 3,000 problems just on Leetcode, and I've probably solved 10,000 or more in my lifetime or whatever on other servers, etc. Right? So trust me, I do not remember most of these problems. I have other stuff in my memory in my life, and yeah. And you know how you can not remember these and still solve them? By actually problem solving. And then, you don't have to remember them. Trust me. Or at least I don't. I mean, I'm sure, for certain hard problems, if you actually know the answer, obviously it'll be faster because you know the answer. But, it's still doable even if you don't, right? Maybe just a little bit slower. Maybe you make a lot of mistakes like I do. But, yeah. All right. I just take a nap a little bit earlier. Actually, maybe I had a soda. Maybe that's, am I like... I feel a little hyper right now. Maybe it's the caffeine by accident. But okay. But let's take a look at today's problem. It's easy. Hopefully y'all are doing okay. Yeah. Today we have 3507 minimum pair removal to sort array 1. Maybe we'll get to 2 tomorrow. Alright, you have nums. Any number of times adjacent pairs, minimums, what? Select the adjacent pairs of the minimum sum in nums, multiple, so that means that the first thing I would say when, I know this is easy anyway, so you probably would, gauge the limitations. I think it used to be that the daily problems didn't show you the difficulty and it was a little bit better. Maybe, I don't remember if that's true. But in any case, yeah, but this just means that there's no choice, right? And when I say choice, I mean like, decision, as in like decision in a computational kind of way. And when there's no choice, it just becomes usually either data structure or simulation or something like this, because again, you have no choice as to what to do. You just have to do what they tell you, but in a way that's fast and efficient. I'm just going to explain it. I know maybe for this one seems very obvious and basic, but extrapolate a little bit to harder problems and maybe you'll kind of see what I'm getting at. Anyway, we place the pair of the sum, okay? We done the minimum operations to make the array non-decreasing. And again, we have no choice, right? So we just got to keep doing it until it's non-decreasing. Key thing to know is that, of course, n is 50. Because if you, and this is like a general thing, right? Is that if you have like a while I don't know, changed, right? I guess it's true. Like you may write something like if some condition change is equal to whoops, right? Right. So maybe you would write some code that looks like this, and this is an easy problem. So I'm just kind of over explaining a little bit, but also obviously hoping that over explanation helps a little bit, right? But the idea is that okay, this some condition, obviously there's a a complexity, right? And let's just say without let's say that for a regular problem, this could be O of n squared or something, right? Some weird thing. And for this one, you can do an O of n squared, or you could do better, but you don't need to because n is 50. But my thing is, my point is just try to figure out how fast this converges, right? Well, if this some condition in this particular one, you have n items. After you do this some condition, you have n minus 1 items, right? Or in other problems, you might have you're one step closer to the answer, and you know that your n step starting away. That means that this is going to be O of n loop, and then this becomes n cubed. That's basically the idea that I want to get across. And this is a very general. It's something that comes up a lot on the easier problems, because on harder problems they'll make you do something crazier, right? Because this is just, but it is a framework for saying that, okay, well, if n is equal to 50, then we can just, YOLO brute force it. Of course, again, you also get a hint on the fact that it's labeled easy, but I just want to give you some, idea on how to attack harder problems, right? But in any case, yeah, okay. So yeah, so here we can actually just go, if and maybe I wrote this wrong. Maybe I have to like do something here, right? So then some condition is a check, but some check condition maybe, right? And this could be O of n squared, but in this case it's not actually, right? And of course, but I guess maybe what I meant was that this could be n squared, right? Do something could be n squared, right? But yeah, and maybe just like check, and array maybe, right? And we just have to check that it is non-decreasing. So that means that n is equal to length of r, right? I, and this is just to make sure that it is not what's it called, non-decreasing, something like this, right? Oops, right? And then the opposite of this, actually, I always messed up because I always write what I want to write, right? Okay. Or I guess check is, yeah. Maybe you want the reverse of this, actually, but yeah. This means that if this is true, it means that we're good, right? So if this is good, then we actually want to return, right? So we actually want to break, and then we just return operations. So maybe we have like return operations, right? Operations is equal to 0. We do something, and when we do something, this is an operations, right? And maybe this is a do operation, right? Right, maybe like something like that. And nums is, I don't know. Maybe we can rewrite this. I don't know. Maybe something like this. I don't know. Right? All right. Yeah, Jason. I mean, here again, we'll just write another for loop. We don't have to get too fancy. You probably could do things, and that's okay. We'll go with tomorrow. If tomorrow's part 2, I don't. But that's why these things are always a little bit little awkward for me, because I want to upsolve it and be like, oh yeah, you can also do X, Y, and Z. But then I was like, but that may be tomorrow's video if it's part 2. I don't know, right? And that's what I don't like about these kind of incremental series, right? Like you should do them all at once, really, to be honest, because it's still fresh in your mind, and you upsolve them and stuff like that. But yeah. Also, what did I misspell operations? That's okay, right? So then now maybe best index is equal to 0, right? So then now we can start at 1, right? So if best is best index, right? Oops. So now we go with array sub I plus array sub I plus 1, and you can write this in a lot of different ways. I mix it up a bit. Is less than best index plus then best index is equal to I, and we are Gucci, right? We have a good sentinel and stuff like that, and yeah, and that should be good. Did I? Oh. Why did I return the best index? Oh, I'm just dumb. I forgot what I'm supposed to be doing. But now best index is going to be. Do we replace the pair in place? Is that the thing? Because 3 1's at the end, 2 4's at the end. So they don't really tell you, right? Like I guess it's in place, but it is a little bit, because you could also say like, oh, put it at the end or something. I mean, for now I'm just gonna say put it in place. But yeah. So then now we want to remove. So we don't want to include best index. We also want to not include best index plus 1, right? So it's gonna be plus 2, say, right? And then now we have the sum, right? Which is something like this, right? I'm trying to. I mean, this is fine, but I'm trying to think whether like. So what I'm thinking right now is just thinking of what happens when we have one element and whether this kind of messes up, right? Because we have one element. I mean, it goes from 2 to 1 element here, and then it should check, which is trivially true. So I think it should not happen. But these are the things that I'm thinking about, right? Am I always just off by no? It's already stored. Okay, I didn't mean to do this. So then now, also I don't. This should be changed as you go to true here. But I mean, we don't even need. That's just like a general thing. We don't need to do it here, right? So we can just do this, and that's fine. Because the check, it's part of it anyway. Okay, maybe not. Huh? Why am I returning 0? I cannot even do a easy problem today. Let's see, right? Maybe this is. Do I have some off by 1? Maybe. I mean, this is just not. The check is wrong. That I is greater than I plus 1. We return false. Oh. I guess I just did it the opposite way. Whoops. Yep. Okay. This is what happens when you name things check, is that you don't know what it's checking for. It should be check non-decreasing. That's really word. Let's just say check sorted, right? So then now, if it's not sorted, right, then now at least you know if it should be not or not. Not or not. All right. Anyway, this is obviously a very oversolved and over-explained problem. I just want to kind of give you a lot of ideas. And you know what? Honestly, it's not such a throwaway because tomorrow, if we do the same problem, I'll just be like, hey, check out the video from yesterday. I don't know why I'm telling you this, though, because I might say that tomorrow. So, okay. Anyway, that's fine. Anyway, that is all I have for this one. As we said, check sorted is O of n. Do operation is O of n. So inside the loop is O of n operations. And again, this gets closer one step every time, and the n steps at most, because you just go from you get shrunk. So n squared, right? That's it. That's all I have for this one. I imagine part 2 is tomorrow, so I'll save it for tomorrow. Thanks for watching. Stay good, stay healthy, to your mental health. I'll see y'all later and take care. Bye bye.